This starter game is a game called Candy Jar, and it's based off this super cute scratch game that's like a very simple, like defend the middle kind of game. You have projectiles, you have cloning, you have score, you have lives, some basic UI. And I figured I'd adapt this for Unity because this is a very simple entry point. The Unity project looks something like this. There is background music that you can hear. I'm going to turn that down though. So it works very much the same way. There are things spawning in. I have an ammo count. Oh, at the bottom. If I get hit by too many things, I eventually will run out of lives. There is a high score counter, some UI elements, a restart button. Pretty solid first project if you are new to Unity. So this is the game that we're looking at building. Let's go ahead and get started. In your Unity hub, go ahead and click New Project. This will be a 3D project and give it a name. Make sure it's saved in a location where you know where it is, and then click Create Project. I am going to fix my layout, so I'm going to go to Layout, Tall, drag my game view down below, and bring this up. Okay, sweet. Next thing, go to Scenes, right-click, and let's rename this. I'm just going to call this Game. Cool. All right, we're going to start with a game object that's going to hold the center of our world, so I'm just going to right-click and create an empty, and I'm going to call this Center. It'll be at 0, 0, 0, and we're going to add a script to it. This will be the thing that shoots out those little candy corns that you saw. So in our Assets folder, right-click and create a new folder. I'm going to call this Scripts, and then right-click the Scripts folder and create a C# script, and I'm going to call this Shooter. This Shooter script we're going to attach to the center game object that we made. There we go. And let's go ahead and double-click and open it up. Let's start with the basics. We're going to create a projectile that we can shoot. So let's make a private game object underscore projectile, and then go ahead and, of course, serialize the field so that we can assign that in the inspector. This center is also going to rotate to face where our mouse is, like you saw in the example demo. So with an update, we are going to rotate to face mouse. In order to do that, we need to store that information in a vector3, which takes an XYZ position. And we're just going to call this like mouse position, and that will equal where our mouse is based on where it is in the viewport, right? Like it's going to take in the camera, and then it's going to take in the screen, and it will convert that to a world point position. If you go into the Unity scripting API in camera, you're going to find this method called screen to world point, which takes in a vector3 dot position. And if you read the description, it transforms a point from screen space into world space. We are going to say camera.main.screen to world point. And we're going to take in our input.mouse position and end that with a semicolon. Oh, this is upset because I accidentally somehow added a system.numerics at the top, so I'm going to delete that. Now that we have that mouse position, we are going to apply that to the rotation of that center object. So we're going to say transform.rotation equals, and the rotation data that is right here in your transform, this rotation, takes in a thing called a quaternion. This is not something to be afraid of. It's just how we measure our rotation data. And once again, if you look in the Unity scripting API under quaternion, you're going to find this method called look rotation. And the description is it creates a rotation with the specified forward and upward direction. Forward is the direction to look in. Upward is the vector that defines which direction up is. This is kind of what we want. So we're going to say quaternion.lookRotation, and the forward direction is vector3.forward, and which way is up is going to be our mouse position minus our transform.position, SITI. Now, if you recall from the example, this little ball right here, its pivot point is actually the center of the screen, and then the ball is kind of offset. So in order to do that, we're actually going to create a child of the center object. So I'm going to create a 3D object that I used a sphere. You can use whatever you'd like. And I'm going to call this our shooter. So I'm just going to offset this shooter on the Y position by like 3. And then I'm going to set its scale to be like a little bit smaller, 0.5, 0.5, 0.5, and 5. When I hit play, you may have noticed that the ball is not actually rotating at all. The center is also not rotating at all. In the shooter script, I just threw in a quick debug.log down here to get the idea of where it thinks the mouse position is, and take a look. It thinks that my mouse position is staying firmly at a solid 0, 1, -10, which coincidentally is the exact position of my camera. Now, when stuff like this happens, it's really Google that's going to come down and be your best friend. being able to know what to Google is really going to help you out. So I've Googled, my mouse input position is not working. And you see a dude who has kind of the same problem that I do. And it seems like the solution is that since we're kind of simulating a 2D environment, we should have an orthographic camera. Right now, our camera's probably set to perspective. So let's take a look at our camera, which is set to perspective. If we set it to orthographic, see if this makes a difference. It totally does. And now our rotation is totally working, and you can see the mouse input debug.log is accurately displaying where my mouse position is. Beautiful. While we're on our camera, let's go ahead and set the clear flag skybox to a solid color, and then you can turn that to be kind of whatever color you'd like. The next thing that makes sense is we're probably going to want something to actually shoot when we click, right? So let's go ahead and create our candy corn projectile. I'm going to use a 3D capsule, and I will call this projectile. This projectile, because it's going to be interacting with other things, it's going to need a rigid body for collision detection. At least one thing when you're detecting collisions needs a rigid body, one of the two parties. And we're going to uncheck use gravity. We don't want that. We do have a capsule collider, so that's good. But what we'll want to do with this capsule collider is set the is trigger to be true, since that's usually also how you detect pass-through collisions. Now we need to set the behavior of this projectile. So let's create a new C# script, and I'm going to call this projectile. Let's attach this script to the projectile, so and then double click and let's open it up. All right, the projectile's behavior is simple. It needs to move at a speed, and once it gets, let's say maybe 5 seconds of moving wherever that is, it's probably off the screen and we can go ahead and destroy that object. So we need to create a variable for speed, which is usually a float. We'll say private float underscore speed. We might want to change that later, so we will serialize field. And in the update loop, we're just going to move it. So transform.translate is a method that moves in the direction of translation. So we just want to move it, let's say vector3.up. And we want to multiply that by our speed and factor in real time, time.delta time. The next thing that we want to do is wait 5 seconds and destroy itself. There is a thing, if you're not familiar with it, called a coroutine that allows you to use the keyword yield, which is basically like wait. Anytime you hear the thing of, oh, I want to wait a few seconds and then do an action, you're probably going to be using a coroutine. So a coroutine, you would think that it's called like coroutine, but it's actually a IE numerator, and we give it a name. So I'm going to call it like wait and destroy routine, and then we will open up curly brackets. An IE numerator is underlined in red by default because it needs a yield statement in order to be satisfied. So I'm just going to put a yield, return new, wait 4 seconds. And how many seconds do we want to wait? Let's say 5.0f. After that, we want to destroy this .gameObject. Cool. Now, this IE numerator does need to be called, and I guess let's call it in start. So right after it's created, it will automatically call this and count 5 seconds and destroy itself. All right, there we go. Let's go ahead and save this script, pop it to Unity. And this projectile is kind of big, so I'm going to size it down to be like 0.5, 0.5, 0.5. And let's just see when I hit the play button, it should move, and then we should see it destroy from the hierarchy. Oh, interesting. It didn't move at all. It did destroy after 5 seconds. And the reason it didn't move is because the default of speed was set to 0. So I'm going to set that back to 5. Now let's hit the play button. And there it goes. It's moving up, and eventually it destroys itself. Sweet. Now that we have a projectile, let's make it into a prefab. So I'm going to right click in the assets folder, make a new folder, call this prefabs, and drag the projectile inside. So now we have that. And we can delete it from the hierarchy. Prefabs are what you can instantiate or clone. So let's actually go ahead and instantiate this. On our center object, it's looking for a projectile. So let's drag that projectile in. And now let's open up our shooter code once more. And we want to instantiate this projectile every time we click the mouse. Here, I can delete that. So in update, we need to check, hey, did I press the mouse? The way to do that is to say if input.get mouse button down. So the moment you click a mouse button, and we will say it is mouse button 0. If you look in the scripting API for this, 0 is the left click, 1 is right click, and 2 is for your middle click. So we want 0 because we just want a regular click. And then what we want to do is we want to instantiate our projectile And we want to do it at our transform position, so at the center. So we will just say transform dot position, and what rotation it wants is also our rotation, transform dot rotation. So as we're rotating around, it will be pointed in the direction that our shooter is pointed. Let's test this out. There we go. I'm clicking and it is instantiating at the middle and moving out in the direction of my little shooter ball thing. Perfect. Next up, let's make the thing that we're protecting. So we're making the thing in the middle, the jar that's slowly rotating and is in charge of having lives, right? Because that's the thing that this shooter is protecting. So I'm just going to create a 3D object. I'm going to make it a cube because eventually we'll make it something else later. I'm going to call it jar. And this jar needs a couple things. It does need a box collider that is a trigger so that we can tell if it's been hit. And this jar also needs a script. So I'm going to right click and create a new C# script. Call this jar. Attach the jar script to the jar object. So it's right down there, and double click and open it up. This jar script is in charge of two things. It's in charge of rotating at a speed and having lives and taking damage. So let's create a speed variable, private float underscore speed, and I'll set that also equal to like 5, but let's serialize the field so we can change that if we want to. Let's also create a private integer of lives, and I guess I'll set that to 3. We probably don't need a start method. We're good here. We're just going to deal with update. We are forever rotating. So we're changing our transform. If you look at the scripting API for transform, there is a .rotate method, and the description is you use transform to rotate game objects in a variety of ways. It's often provided as an Euler angle and not a quaternion. So the Euler angle being like the XYZ, the vector 3. So I'm just going to say transform.rotate and then open up parentheses, and we will say vector 3 dot. The axis that we want to be rotating on is probably our Z axis. Yep, since you can see on the screen that's slowly rotating on the axis we want. That axis is vector 3 dot forward. And we will once again multiply that by our speed and multiply that by time dot delta time. Let's hit save. And when I hit play, it is slowly rotating. Cool. And then you can of course change the speed in there if I want it to rotate like much faster. There's 25, 100, whatever you want for that. Now it's time for us to create a public method that will take damage. So we're going to say public void damage. And this method, we're just going to say lives minus minus. That is the same as taking away 1 life. So something else is going to be in charge of calling this method and taking away a life. And then eventually in here, we will communicate to the UI to take away lives. Cool. Well, that's that script for now. The next thing that we want is probably those obstacles that are flying in all around us. So once again, let's create a 3D object to stand in for our obstacle. And I guess for this, I will use a cylinder. And I'm going to call this obstacle. Now, similarly to our projectile, this obstacle also needs a collider, whatever that collider is. Width is trigger checked since it's going to be having collisions. It might also want a rigid body, once again with gravity turned off, and it will want an obstacle script. So let's right click in our scripts folder, create a new script, and let's call it obstacle. On this obstacle, let's attach the obstacle script, and it's here. Double click and open it. Cool. This script is a little bit more complicated than our projectile, but it does a lot of the same things. We will want a speed variable, right? And I guess I'm going to set that equal to 5 as the default, but maybe what we should actually do is give these obstacles a slightly random speed, some a little bit faster, some a little bit slower. So let's go, and in start, we're going to set speed at the beginning equal to a random dot range. And because speed is a float, it's inclusive of the minimum, but it's exclusive of the maximum. What that means is if I set it to 0.1f for the minimum, for the maximum, it's going to go up to, but not including, let's say like 2. Yeah, so it'll go between 0.1 and 1.9. I don't know why I set it to 5 if I'm going to set the max to 2, but whatever. The other thing we could do is see how these are randomly rotating to sort of give it a little more interesting for the player so that you can see the geometry, you can see these different angles. Let's give it a random start rotation and slowly kind of rotate it over time. So at the beginning, let's say it's transform.rotation equals a random rotation. Cool. Cool. Now, in update, what it needs to do, there will be a spawn manager that's in charge of spawning these obstacles in at a certain speed from a random location around the outside. So we don't need to set its start location. The spawn manager will do that. So all this thing needs to do is it needs to know where the center is and it needs to go there. There is a method in the vector3 class called vector3.moveTowards. Basically what it does is it takes in where you are, where you're trying to go, and it will move there based on a speed. So to use this method, we're going to change our transform.position, and we're going to set that equal to vector3.moveTowards. And so like we said, it takes in our current position, which is transform.position. It takes in a target. Our target is the center of the screen, so we can just say vector3.0. And it wants to know what speed we're moving at. We do have a speed variable, and as usual, we will factor in time.delta time. The other thing that we could do, like I saw in the example, is we can give it that rotation. So transform.rotate, kind of like how we did for the jar. And we could rotate, it kind of depends on how you want to rotate yours. So I'm going to actually pass in, instead of doing the shorthand of like vector3.up or down, let's say we want to rotate it on both the X and the Z axis to give it some more interesting rotation. So I'm going to say new vector3, and I'm going to pass in a 1 on the X, not going to rotate on the Y, and it will rotate on the Z. And then we can specify how fast we want it to rotate, which I could do another speed variable. I could actually do a private float rotation speed. Maybe we'll set that equal to 25F and serialize the field there. So I will multiply this by our rotation speed, and once again, time.delta time. Let's see if this even kind of does what we want. I'm going to move the cylinder sort of off, and we should see it slowly spin towards the center. There we go. Beautiful, like an object in space. We love to see it. And when it gets to the middle, it's going to stay there and rotate. Beautiful. So now we need to set up our collision detection so that it can actually tell, hey, I've hit the thing in the middle. So we have that trigger collider that we set up, and there's a method for that called void on trigger enter, and it takes in a collider, and I usually call this other. So it's storing the thing that we hit. Its collider is stored in this variable called other. So we can use that data and we can check maybe if the thing has a tag, like if that thing equals, let's say player, we'll tag it as player. That'll be that jar thing in the middle. And if it is, then we can damage it. So let's go really quickly to our jar in the middle and let's tag that as player. Bam. So when the obstacle hits that, it'll know because it's going to check through the collider what its tag is. And then it can do something like on our jar script, it can call this damage method. So we're going to do that. In order to call this damage method on the jar, we actually have to get access to the script on the object that we just hit. And we can do that through the collider, right? So we now have that in other, and we can get reference to a jar script, and I'm going to set that equal to other.get component, and we are looking for jar script that's attached to the object. It's always a good thing to null check, because what if for some reason that object doesn't have a component and then you're going to try to call a damage method on a script that doesn't exist? It'll throw an error and your project will break. So we're just going to say if jar exists, meaning if it's not equal to null, then we can say jar.damage. We can take a life away. And the other thing that we might want to do is we're probably going to want to destroy this obstacle so that it's not just rotating around in the middle of the screen. So we will say destroy this dot game object. Oop, not capital G. There we go. So we're going to save this and let's see if it moves towards us and destroys itself. Go. All right. It's moving toward us and bam, destroying itself. Our lives are a private variable. We can't see that. We could serialize it so that we could see that. So I guess let's do that real quick on our jar script. Let's serialize the field. On our jar, lives are set to 3. So when I hit play, let's see it deduct our lives to be 2. Here we go. 3. Bam. And now lives are 2. Perfect. The other thing that our obstacle needs to do in this trigger event is it needs to know about the projectile so that we can actually destroy it before it gets to the center. We can do this in the same way. We can say if the thing that we hit is not tagged player, but maybe let's give it a projectile tag. So let's go to our prefabs. This projectile, I've double clicked and now we're in this like look dev view. So I'm editing this prefab. The tag, we don't have a projectile tag, so I'm just going to add one, click the plus sign, type in projectile, hit save, and back on our game object, we can now tag it projectile. Beautiful. So back in our script, if the thing that we hit is the projectile, eventually we will communicate to the UI manager to update the score. But for now, let's just say we will destroy this .game object. And now let's see if that works. If I hit play, to be able to hit it, bam, and it's destroyed. Yay, perfect. So now that our obstacle is pretty well set up, it is time for us to turn it into a prefab and spawn it through a spawn manager. So it's a prefab now, and I can delete it from my hierarchy. And now it's time for us to create a script for a spawn manager. The spawn manager doesn't need to look like anything, so I'm just going to create an empty and call it spawn manager. In the scripts folder, right click and create a new C# script, also called spawn manager, and let it compile, and then attach that script to the spawn manager. Now that it's on there, let's double click and open it up. So the spawn manager needs to have access to the obstacle to spawn. So let's create a private game object called obstacle prefab, and we will serialize the field so that we can assign it in the inspector. We might also want some kind of speed variable for the speed at which we spawn speed, and I'll set that to 1.0f. So it's going to spawn something every second. And when you hear something like that, like every second it's going to do something, probably means we're going to use a coroutine since we need to yield for 1 second and then do an action. So probably don't need update. We will want a coroutine instead, which is an IE numerator, and I will call it spawn obstacles routine. Once again, it's upset because it needs at least one yield statement, but what we want is a loop. If we were in Scratch, we'd be looking probably at some kind of repeat until loop, and we will probably use a while loop for this. Now, a while loop is also pretty dangerous in that if you don't have one yield statement in it, it's going to eat up all your processing power and crash your computer. So we will yield, return a new, wait 4 seconds, and we will pass in on speed. So this yield is satisfying both the IE numerator and the while loop. And we could just say while true, and that's going to be infinite, but eventually we will probably want to stop spawning when the game is over, like when we run out of lives. So I'm just going to make a private bool, which is a true or false kind of variable, and I'll call it can spawn, and we'll set it equal to true at the beginning. So while can spawn, we will wait however long our spawn speed is, and then we are going to instantiate our obstacle. So we will instantiate our obstacle prefab. Now, the next thing that it takes in, if we look at the override number 9, it takes in a position to spawn at and a rotation. Now, we don't really care about the rotation because the obstacle script itself is going to be handling its own rotation, but we do care about the position. So for right now, I'm going to end this, and let's create a custom return type method to give us a random spawn position. Now, this one's a little bit tricky because we want it to spawn from top, bottom, left, and right. So random X and random Y, but based on where it's like, we don't want it to spawn in the middle. It has to be off the edge. So this one gets a little bit complicated, but bear with me. We got this. We're going to create a private return type. What it is returning is a position, which is an XYZ. So it's going to be a private vector 3 since it will be returning a vector 3, and I'll just call it get spawn position. There we go. Now this one is upset, not because it needs a yield statement, but because it's not returning anything right now. It needs to return a vector 3. So let's calculate this. It's either going to be coming from up, down, left, or right. So there are 4 possible directions. So let's create a temporary variable called direction. It's an integer because it's a whole number, and that's going to equal a random.range between 0 and, remember, if it is an integer, it's exclusive. So it would include 0, 1, 2, 3, and if I just put 4, it would be 0, 1, 2, 3, and that gives us 4 directions, right? If I do 5, it's going to give us 0, 1, 2, 3, 4, which is 5 directions. We don't need that. So I'm going to go between 0 and 4. Yeah. So we're going to get a random direction, which I did spell wrong. Direction. Now we also need need a random X. That's the width of our screen, kind of, which I'm just going to estimate is like -10 and 10, but it might be bigger or smaller depending on yours. So if you're finding that yours aren't spawning across the width, you can change the number. So I'm going to say float random X equals random.range between -10 and let's say 10. And we will also do another float for the random Y. So the height of the screen, which again, I'm just going to guess is between -10 and we can change that later. Okay, so now we're going to decide which one means what. I'm going to say 0 is up, 1 is down, 2 is left, and 3 is right. So now, instead of using a bunch of if-else kind of loops, we're going to use a switch statement because it's a bit cleaner. So we're going to check the direction that was chosen. There's 4 possible directions, and the syntax for this is case. The first case we want to check for is 0, and then colon, and then break, semicolon. The next case is 1, case 2, case 3, and somehow, if we need it, let's just say a default case, and then break. All right, within each of these, so we said 0 is up. So what that would be is it would return a new vector 3, and it's coming from the up direction. So what that needs is a random X, and then the Y needs to be a big positive number. So let's just say random X, Y is like 10, and we don't care about the Z. Cool. 1 is coming from the down direction, so we can also say return a new vector 3, and that is random along the X, -10 on the Y, and we don't care about the Z. All right, hopefully you can kind of see a pattern here. You might be able to fill in the last 2 on your own. For case 2, which is left, we're going to return a new vector 3, which is not random on the X. Let's just say it's -15 all the way left, but it is random on the Y, and don't care about Z. Lastly, we are spawning from the right, which is return a new vector 3, +15, so all the way on the right, and randomly along the Y, so anywhere up and down there, and we don't care about the Z position. Now for the default case, if for some reason, which is not really possible, but if for some reason a number is chosen that is outside of this range, let's just say that the default it's going to spawn from is up. I'm going to copy that and put that in the default. Yeah, so if for some reason this method is broken, the default spawn position will be from above. Cool. Now that we have this get spawn position method, when we instantiate our obstacle prefab up here, we can specify get spawn position as its starting place. And lastly, the rotation is what it's looking for, and we don't care about the rotation, so we can say quaternion.identity. Cool. All right, this was a lot. The last thing that we need to do, this one upset. Oh, random.randomRange? Why is this one upset? Use random.range instead. Oh, okay. Let me just say random.range. Beautiful. Okay, love that. Okay, last thing that we need to do in start, we actually need to start the coroutine that we created right down here called spawn obstacles routine. Parentheses, semicolon, hit save, hop back into Unity. Make sure that in your spawn manager, your obstacle prefab has been dragged in from your prefabs folder just like that, and let's hit play. Ooh, and we can see in our scene view that they're spawning. Seems to be random. Oh, beautiful. Okay, it seems to be working. Love this. Okay, cool. So I would call this our core functionality. Everything is kind of set up, and now it's time to get into making this kind of pretty. I would say let's start with the UI, and then we'll work on adding custom geometry to all of these things. So let's start with the UI. We're going to create a new folder that's going to hold our textures. So I'm going to type in textures, and in this folder, you need to find a texture for your lives display, for your hearts, right? So here's the one I have. You can screenshot it if you want, or you can use your own as well. It has to have a transparent background. So if you have an image that has a background, head over to remove.bg. You can upload your image and it will automatically remove the background for you. It's pretty neat. So I'm going to drag that image into my textures folder. And then on this, since it has a transparent background, we do need to set alpha to transparency. The texture type is 2D and UI, and go ahead and hit apply. Awesome. Now that we have that, let's go ahead and right click and create an UI object, and that's going to be our image. I'm going to call this heart. Now, before we do anything crazy with this, I'm actually going to go to the canvas and set its UI scale mode, change it from constant pixel size to scale with screen size, so that as the screen gets bigger or smaller, our UI elements will scale depending on what kind of screen this is on. The heart is looking for a sprite, so I'm going to drag in that right that I have. And I'm actually going to anchor this one. So I'm going to click on this little gadget here, hit Option and Shift, and click the top left corner. Beautiful. That heart's looking great. I'm actually going to name it Heart 1, and then I'm going to right click and duplicate it. It will be Heart 2. And I'm going to find it where it is, hit my 2D button, hit W, and then sort of drag it over to like where I want it. Let's say like there. And then I'll do the same thing. Right click, duplicate this guy, call it Heart 3, and drag this one over as well. Something like that. I'm also going to organize it a little bit better too on the canvas. I'm going to create an empty object and call this Hearts. And then I will take all the hearts, shift click, and child them to the hearts object. So that if I ever want to move all the hearts, I can just drag all of them together. Cool. Let's also, while we're here, let's right click on our canvas and create a UI Text Mesh Pro. And the first time you do that, this TMP importer is going to pop up. Click import and import the examples and extra. All right, this text is going to be our score text. And I'm going to set the default text to say score, colon. I'm going to anchor this text to the top right. Click that top right. I'm going to set the width to be a little bit wider, like maybe 450. And then its height is a little bit less. And then I don't really want it to be like this wide. So I'm actually going to set its alignment to be on the right, so that as my score changes, this will get bigger, but it'll be like justified to the right. I'm going to set the font size to be bigger, like 60. That. I'm going to set its color to be orange. If you want to take a moment, you can go and look up a custom font. So I went to dafont.com and I looked up Halloween themed fonts, which there are some good ones. I think the font that I used in the original was called Chocolate Bar. So if you want this font, you can grab this one. If you want something else, you can grab that as well. And then I'm going to go ahead and click download. I'm going to create a new folder in the assets folder and call this one fonts. And then find the file after you've unzipped it, drag it into your fonts folder. So now I have this Chocolate Bar font. Now the thing is, this font is not a Text Mesh Pro font. So if I try to select it from the font asset, I'm only going to have the default ones that came with the Text Mesh Pro import, and I'm not going to be able to find chocolate. So I think if we go to Window, Text Mesh Pro Font Asset Creator, it's going to open up this little window and it's going to ask you for the source font file. We can drag in the chocolate font and click Generate Font Atlas and then hit save. And I will save it in Chocolate Bar, hit save. Now we have a Text Mesh Pro font that we can use. And where is Chocolate Bar? Chocolate Bar. There it is. Beautiful. And now my score is using the custom font. All right, before we get into the fancy stuff like an ammo count, a game over screen, and a high score, let's program our lives and our score since we already have the functionality set up for that. So surprise, surprise, on our canvas, we do need another script. I'm going to create a script and I'm going to call it UI Manager. Now with your manager classes, there's a thing that I like to do, which is the singleton game design pattern, which allows your class, your manager script, to be easily accessible by your everything in the entire game. So we're actually going to take a moment and set up this UI manager as a singleton, which will make everything kind of a lot easier. And this is definitely more of an advanced thing, but it's something that's good to know. So to create a singleton, we're going to create a private static UI manager, and I'm going to call it underscore instance. Static means that this is going to be accessible across all of our classes. This one is private, so let's create a public property that is static. That is a UI manager called capital I instance. Now, this property is only going to have a get method, no set method, so it's only going to return this instance. We do need to null check and make sure that this instance exists before we return it. So we're going to say if the instance equals null, then we can shoot a debug.log error and say UI manager is null. And then outside of this if statement, we can return the instance. The last thing that we need to do to convert this into a singleton is in our void awake method, we need to set the instance equal to this. Now, I know for some of you, if this is your first time working with singletons or static variables or properties or anything like this might be a little bit confusing. But the way to think about this is if you only ever have one manager, like this UI manager, there's not going to be multiple of this. Your game is just using one. It makes sense to convert it to a singleton, and you will see why in just a second. Awake is called before start. So after awake, between start, I'm going to put the variables that we want. So we want a private text mesh pro, but we can't actually access the Text Mesh Pro without this namespace up at the top. We are using the TM Pro namespace, which gives us access to the Text Mesh Pro library. Yay! And what we have is we have our score text. We also want access to our lives images that we made, and I'm just going to access them at the game object level instead of the image component level. So we're going to say private game object, and I'm going to call this underscore lives 1. And because they're the same data type, we can actually just string all the 3 lives together like this. Perfect. So 3 lives. And because they're both private, let's go ahead and serialize the field on both of them, that we can assign them in the inspector. So let's hop back into Unity. On the canvas game object where our UI manager script is, it's now looking for a score text and 3 lives. I'm going to lock the inspector so that it's easier to drag these in. So now I can grab the score text and drag it in there, open up hearts, heart 1 in lives 1, heart 2 in lives 2, and heart 3 in lives 3. Great. I'm going to unlock the inspector so now I can click and things will change. Back in the UI manager, we need 2 public methods that our other scripts can call. One of it to update our score and one of it to update our lives. So we actually don't need this update. We're going to make some custom methods instead. These methods need to be public. Let's start with updating the score first. Public void update score. And we do need to pass in an integer of like score to add so that the UI manager knows how much score there actually is. Let's also, I guess, have the UI manager be in charge of score. Kind of not best practice. Usually you have your player class in charge of the score, but in this case, it kind of doesn't really matter. So we're just going to create a private integer called underscore score. And at the beginning, I'm going to set that equal to 0. Now in update score, we can set our score plus equal to the score to add. So it's going to add however many points you pass through when you call this method. That way your obstacles could be worth different points if that's something that you want to add. And updating the score integer is not enough. We actually have to access the text and set that equal to score and append that to our score variable. Now that we have this public method, we can call it from our other classes. Now, how do we actually know when we add a score? Well, our obstacle class knows when it hits a projectile. So we can call that score method that we just created. So we can actually say UI manager.instance.update score and pass in how much score we want to add, which for me, I'm just going to say 1. Now, this is why we converted that UI manager into a singleton, because we can directly, with just 1 line of code, communicate to the UI manager class to update the score. Whereas in the past, we would have to get the game object, grab the UI manager component, check if it's null, and then call that method. This is much cleaner. So hopefully you can see why we do it this way. Let's check if this works. All right, here they come. If I hit it, yay! And now my score is going up. Beautiful. That's working really, really well. Next up, let's program our lives. So back in the UI manager class, let's create another public method called void update lives. And same deal, we'll take in a parameter probably called like lives, just so we know what our current lives amount is. Now for this one, we want to be turning off the game objects as we lose lives, right? So we can probably also use a switch statement and we can check our lives. The cases that we have is we have case 2, if we only have 2 lives. We have case 1 if we have 1 life, and we have case 0 if it's game over. Great. And probably also, just in case, we will throw a default, just in case the lives are out of range of these cases. This will catch it. So for case number 2, what we want to do is we want to turn off the game object that is lives number 3, because 3 just got cut. So we're going to say lives .setActive is false. That's it. For case 1, we want to turn off the second lives 1. Lives .setActive is false. And for case 0, we're going to be getting into some game over stuff, but the first thing we can do is say lives 1.setActive is false. Awesome. Now, who's going to actually call this method? Probably that's going to be our jar, right? Because our jar is in charge of having its own lives. And here is where the damage method is called. And now we can communicate to the UI. So same as before, we can say UI manager.instance.update lives and pass in current lives. Easy. Let's go back to Unity. All right, here we go. Lives is 2, 1, and 0. And as it goes into -1s, right, like here is where the game over state would be called, but definitely my lives are going to be going into the negatives, so it's time for us to program a game over state. So on our canvas, let's go ahead and right click and create a UI Text Mesh Pro to be our game over text. Text is going to say game over. I'm going to set the font to be that chocolate font that I downloaded. Let's set its color to be like red, set its size to be pretty big, like 80. I'm going to center justify it and then set its width to be something bigger, like 450. Sweet. I think we'll also want a button underneath game over that we can click to restart the game. So as a child of the game over object, so like right click game over text and create a UI button text mesh pro. And I'm going to call this restart button. I'm going to move it down so its Y position will be like -100. I'm going to set its height to like 50 so it's a little bigger. Color of the button to be like a nice red so it matches. And the child object of the restart button is the text. So this text will say restart. Set the font asset to be chocolate, and maybe let's set the color to be like some yellowish. I'll set the font to be a little bit bigger, like maybe 30. Nice. By default, select your game over text and turn it off so that our script will be in charge of turning that game object on. So in our UI manager, let's grab access to another game object. So I'm going to put a comma after this and call this game over text. And now in the update lives method, in case 0, where it is game over, is we can set game over text.setActive equal to true. So that should turn on. Now after this, a few things need to happen that we get to program in soon. We need to stop spawning the random obstacles. We need to stop shooting so we can't continue to gain points afterwards. If we had music, we could change to game over music. We can check if we set the high score, and I think that's about it. Yeah, let's test it. Let's make sure to go to the canvas, and it's looking for game over text, so don't forget to assign that game object. And now let's hit play. All right, here we go. 3, 2, 1, game over! Yay! Now, when I click the restart button, nothing happens, and also I can still shoot everything, so let's start to clean this up. Let's start with the restart button functionality because that's pretty easy. In the UI manager, in order to reload a scene, which is basically what we want to do, we do need access to another namespace, and that's the using Unity engine.scene management. And down at the bottom, before the last bracket, let's create a public void that the button is going to call, and I'll just call this like restart the game. And all we're going to do is say scene manager.load scene, and I'm going to specify 0, and the reason why I'm going to specify 0 is in our build settings, the scene that we want to load here in our build settings, we need to add the open scenes. So now it has the game scene, which is a build index 0. So make sure you add your open scene so it knows what scene is 0 and it will load the correct scene. Let's hit save. Now on the restart button, it's looking for an on-click event. So hit the plus sign. It's looking for a game object that has the method we want. So I'm going to drag the canvas in, and the function is on the UI manager script called restart the game. Here we go. Now when we hit play, we're going to go 3, 2, and 1. And now I can click restart and the game is restarted. Beautiful. The next thing is let's make it so that we stop shooting so that we can't gain score after it's game over. So in our shooter class, we need a public method called stop shooting. Public void, stop shooting. And simply, I think what we'll do is we'll make a bool variable up at the top, make a private bool called can shoot. And by default, that'll be true at the beginning. So over here where we're clicking the mouse, we can also say and can shoot. So if I click the mouse and I'm allowed to shoot, we will instantiate a projectile. When the public void stop shooting method is called, simply can shoot equals. Now, to call this method from our UI manager, we could do the thing where we get the game object, we find the script, we check if the script is null, and then we call that method. But a simpler way is to just turn this shooter script into a singleton as well. So if you want practice with that, we're going to do that again. Up at the top of our class, we will create a private static shooter called instance, and then we will create a public static property for shooter called I instance. It only is going to have a get property. We're going to check if the instance equals null, and if it does, we will debug.log error is null. And then outside that if, we will return the underscore instance. Lastly, in awake, we will assign instance equal to this script. Because there's only one of these shooters. It's not a multiplayer game. There's only one of this. It makes sense for me to do it this way. So now that this is a singleton in the UI manager script, we can very simply just say shooter.instance.stop shooting. And now at the end of the game, when it's game over, we can't shoot any more projectiles. All right, so I'm shooting a bunch. And at the end, 3, 2, shooting, 1. Now I can't shoot anything anymore. Beautiful. So we have this, stop shooting. The next thing is let's stop spawning those game objects. We don't need them anymore. Our spawn manager is not a singleton, so let's turn it into a singleton real quick. At this point, maybe you'll know how to do it without following along. It's a private static spawn manager underscore instance. We need a public property static spawn manager capital instance. Only the get. We're going to check if underscore instance equals null. If it does, we will debug.log error spawn manager is null. And then outside that if statement, we will return underscore instance. In the awake method, void awake, we're going to set instance equal to this. And now we have this can spawn variable. So literally just like we did in our shooter, I'm going to go down to the bottom and create a public void method called stop spawning. And in here, we're going to say can spawn equals false. Perfect. So from our UI manager, we can say spawn manager.instance.stop spawning. And it's going to work the same way. You could test it out and you should see, even though there are some that are still going to be left over, it's not going to delete the ones that were already made. Those are going to fly in and delete themselves and then nothing else will spawn. So it's like a nice slow stopping of the game. I would say the next thing that we need to look into is creating a high score functionality. So in Unity on the canvas, we're going to create a high score text, which I think will be a child of the game over text, you know? So I'm actually going to duplicate this game over text. Oh, oops, delete the restart button, make it a child of the game over text, and I'm going to call it high score text. I'm going to set the text to high score colon. This one gets to purple. Make it smaller, half the size, 40. I'll set its Y like 40 as well. So it appears above the game over button. Nice. In our UI manager, let's go ahead and grab access to this. Oh, we can do the same here. Score text, comma, high score text. Save, Unity, and on the canvas, it's looking for a high score text. So let's drag in high score text. Now, the high score is something that we want to persist even after we stop playing the game and then we start it again. It should remember that like a week ago, the high score was set to like 85 or whatever. It shouldn't be set to 0 every single time you start the game. So we're going to use a thing called player prefs for this. So to do that, we also want a private integer, probably called underscore high score. And at the beginning, we will set it to 0, but we're going to check if player preferences has a key. So we're going to create a key called high score key, and we will set that equal to high score. And in our start method, this is where we're going to check if we already have a high score in our player preferences. So we're going to set our high score equal to player prefs dot get integer, and we're going to check the high score key. If there is already something stored in the high score key called high score, like if we set something earlier, it'll set it to that. Otherwise, we'll set it to 0. That's just for the beginning. Now, at the end of the game, when it's game over and the high score text appears, it's time to check if we set a new score. So that's really simple. We're just going to check if our score that we currently have at the end of the game is greater than the high score. And if it is, then the high score equals score, right? Oh, oops, underscore. Now, that's not enough to upload it to the player preferences. So we're going to say player prefs.set integer. We are going to set the high score key to underscore high score. And of course, we have to save that. So we're going to say player prefs.save. Lastly, we do need to update the actual text that's on our screen because this is all just on the back end of updating the integer. So we can just simply say high score text dot text equals high score colon plus underscore high score. Okay, that was a lot of saying the word score. Let's hit save and see if this actually works. I'm going to remember to turn off the game over text object so that after I die is when it appears. Okay, I got a score of 1, so my high score should be 1 when I die. Here we go. There we go, and my high score is 1. Let's restart and get a bigger score and see if that updates. All right, my score is now 4. All right, high score says 4. And the last test is let's play it one more time and not get anything, get a lower score and see if it still says 4. Make sure that it's not just setting it to score every time. Here we go. 3, 2, 1. All right, and high score is still 4, even though I didn't gain anything. I'm just really quickly OCD gonna clean up this score text so that at the beginning it does say score is The next thing in this project that makes sense to me is for us to add our ammo count. In the original game, the ammo count is set to 10, and when I click, it goes down, and then it kind of automatically refills, right? There's like a slow refill time up to 10, and when I run out, my ammo speed is set to the refill amount, right? Because I can only spawn as fast as I'm reloading, which is just about 1 a second. Cool, that's what we're gonna build real quick. So now, kind of like how we did it for the hearts, we're gonna want an empty game object. So I'm gonna create an empty, and I'm gonna call this ammo, just so that I can, like position it wherever I want as a group of objects. And now it's time to find the image that you want to use as your ammo. So the image I'll be using is an image of candy corn. So find the image you want, make sure it has a transparent background, and import it into texture. When you first import your image, same deal as we did with the hearts. Alpha is transparency, texture type is 2D and UI, and then go ahead and hit apply. Now that we have this, a child of the ammo game object, I'm going to go to UI image, and I'm going to set this to ammo 1. It's looking for a sprite, so it gets to be candy corn. I want it to be small, so I'm going to set the width to 20 and the height to 20. Nice. And I'm going to set its position on the X to be like -90 and its Y position to be like -200 so that it's down there. I'm also, because it's just a little bit bright for me, I'm going to turn its color just slightly yellow, just so it's not the brightest thing. The other thing too, just as like a note, is this is not a raycast target. This is not a clickable object. So I'm going to turn that off so that it's going to save us a little bit of like processing power. So it's not checking if this is raycastable. So now it's time to duplicate this ammo, and I'm going to call it ammo2, and I'm going to offset the X position just by 20, -70. All right, I'm going to do this until I have 10 ammos. All right, there you go. I have 10 ammos that are evenly spaced, just sort of changed their X position by 20 every time. Great. Okay, now let's go ahead and go back to our UI manager script. So for this, I'm not going to do it in the same way. Let's simplify this a little bit. Let's just create a private game object array, and we're going to call this ammo UI, and I will serialize the field. These array brackets denote that we are storing more than one, and it's up to us how much we want to store. So on the canvas, it's looking for ammo UI. Right now it's at 0. So I'm going to lock the inspector, select the first ammo, hit shift, select the last one, drag from ammo 1 on top of ammo UI till you see that little plus sign, and let go. And now my ammo UI is populated in order from 1 to 10. Important that you're going to want them in order for the way that we're going to code this. So the way we did our lives is we used a switch statement for each option of lives. We only had 3, so that was kind of easy. But for our ammo, because it's going to be constantly refilling and depleting, that's going to be super annoying to code. So let's use a different way to do this. And we will need a public method that can update our ammo count. So I am going to create a public void update ammo count, and it will take in an integer for like our ammo count. So like how much we currently have. Now, instead of activating and deactivating through a switch statement, we're just going to use a for each loop. So the way the for each is, we're going to say for each thing that's in that array that we made. So I believe it's an array of game object, and I'm just going to say for each thing in the ammo UI array, we're going to turn them all off. We're going to reset it every time. We're just going to say thing.setActive is false. So every time we update, it's going to turn everything off, and then it will go back through and turn them on up to the amount of ammo that we have. I feel like this would be an easy way. So this is how you use a for each loop. For turning them back on, just for funsies, let's use a for loop. And the way for loops is it's going to take in an index variable. So int I equals 0. So we're starting at 0. As long as I is less than the ammo count that we specified right here, we are going to increment up I++. And what we want to do for each of those 0, like let's say the ammo count is 5. So for 0, 1, 2, 3, 4, 5, all we want to do is set the ammo UI subindex I. So whatever this indexer variable is, we're going to set that active to true. Yeah, I think this will work. Turn everything off and then iterate through up to the amount that we still actually have and turn just those back on. Yeah, let's do this. So who's going to call this method? It's whoever is shooting, which I believe is our shooter. Yes. So our shooter now needs to know how much ammo does it have. So in our shooter script, I'm going to create a private int called ammo count, and I'm going to set that equal to 10. Every time we shoot is right here in our instantiate call, and I'm just going to say ammo count minus minus. So it goes down by 1 each time. And we do need to limit our shooting if we have ammo. So up here, we're going to add yet another condition and say double and our ammo count greater than 0. So as long as we have ammo, then we can shoot. On our center, you can't see how much ammo we have, but here we can quickly test this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I can't shoot anymore. So our ammo works. Let's hook it up to our UI and then add our refill capability. So our UI manager is already a singleton. So that makes it really easy. Right after we lose some ammo, we can just say UI manager.instance.update ammo count, and we will pass in our current ammo count. It's that simple. And here we go, all the way down to 0. Great, I can't shoot anymore. My ammo's at 0. Now it's time to refill our ammo. Because we want to have like a delay between refilling, it's just not instant, we will be using a coroutine since we'll be waiting just a little bit. So I'm going to create a private IE numerator called refill ammo routine. And in here, we want to be refilling forever, right? We just kind of want to constantly be refilling. So I'm just going to say while true. True is always true. So this is a dangerous one if I don't have a yield statement. So let's add a yield return new wait for seconds. And this is your reload time. So I'm going to put mine at 0.8F. You might want a different reload time than that, quicker or slower. You can put in a different number. And we're just gonna, because we don't want to go up above 10, right? So we only want to refill if ammo count is less than 10. So if we haven't hit our max yet, then we can say ammo count plus plus. And because we're changing the ammo count, we can say UI manager dot instance dot update ammo count and pass in the ammo count that we currently have. This coroutine is not being called, so nothing's going to happen unless we actually call this. Oops. Oh. So when we want to call this is in start. We can just say start coroutine refill ammo routine. I think that's it. Let's go ahead and test. All right, I've clicked to 10. When I let go, it is slowly refilling. Yay. All right. Ammo is set. Love to see it. I think what's left is making our game objects pretty, making them something different than just these primitive cubes. Yeah, I think that's all we got left. All right, for this next part, when we get to customize our 3D geometry, I say let's start with the obstacles because it's a little bit more interesting. So on the Unity Asset Store, I just typed in Halloween 3D and the pricing is free. And there's this awesome low poly Halloween pack that you can use. You're welcome to look through and find other assets that you might want, but I'm going to go ahead and use Poly Perfect's Halloween set. Yeah, this is the one I used in the demo I showed earlier. So let's go ahead and open in Unity. And then it'll open up your package manager, Poly Halloween. I'm going to go, if you hadn't already, click download, and I'm going to click import. This little window pops up and I want all of it. So let's just click import. All right. Once it's imported, then there is this folder called Poly Perfect. And in here, they have all these prefabs. I'm going to choose of their Halloween prefabs. And here's all of these beautiful pre-modeled 3D assets. So to turn these into prefabs that we want for our obstacles, there's a few changes that need to be made, right? So I'm going to drag out the objects that I like and just make a copy of them in the scene so I can sort of mess with them. And this book is really small. So for a lot of these prefabs, we're going to adjust the size so that it kind of fits. So like for this book, I'm going to make it 10, 10, 10. That looks pretty good. And I'll do the same. I'm just going to drag out a bunch of objects that I'd like. They have like little cute mushrooms and lollipops and things. I'll give it the witch's hat. All right. Once you found all of the objects that you kind of want, I'm going to go one by one and resize them. Like this book, 10, 10, 10. A small. Oh, that's too big. It's cool. Witch's hat. The scarecrow. Going this candlestick is like a... All right. So once everything is kind of the way you like it, I'm going to take all of them. So shift click to the bottom, reset their positions to be 0, 0, so that as prefabs, they're centered and nice like that. I'm going to add a rigid body component. Gravity is turned off. Shoot, they all need to have colliders. So let's just make sure and go through. This one has a mesh collider. Yes, 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 yes. This one does not. The witch's hat needs some kind of collider. I'm going to add a mesh collider, I guess. Scarecrow has a collider. All right, everybody has a collider. Beautiful. And now with all of them selected, we are going to add the component of script. Sweet. And then, like, I guess I'm not even sure if I really need to go to prefab unpack because we're updating the root prefabs that are in this folder. Like this, I probably don't need to do that, but I'm going to go and unpack them all so that I can put them in my prefab folder. Bam. Probably didn't need to do that step, but now that they're in my prefab folder, I'm going to delete them all from the hierarchy. And we need to change our script to be able to spawn in a random obstacle now that we have random. So our spawn manager is in charge of that. It has a space for only one obstacle. So instead of having a single obstacle prefab, let's just change that to have array brackets, and then I will make this plural, obstacle prefabs. And now our instantiate call is upset because it's asking like, well, which one? Which one from this list of game objects or this array of game objects do you want to instantiate? So I'm going to say, let's create a random index variable. So that's going to be an integer. I'll just call it random index. And that's going to equal random.range between 0 and the length of our prefabs list. So if you have 5, it would be 5. If I have 12, it's going to be 12. So let's say obstacle fabs dot length. So it's modular. However many you have in there is how much it'll pick randomly between. And then we will say obstacle prefab subindex. And what do we want? We want the random index. Oh, and this is prefabs with an S. Okay, I think that should do it. We do got to make sure on the spawn manager that the obstacle prefabs array is actually populated with the obstacles we want. Okay, I'm going to lock the inspector on the spawn manager, click and shift select all of them, hit command and unselect the 2 non-obstacle prefabs and drag them all into here. Alrighty, now that we have all of those, let's see if it works. Yay! And sometimes the rotations of these can kind of get annoying. So they like rotate underneath your spawn circle thing. So you're going to want to play with the size of each of these. So as you play test, you might want to select like, oh, a specific pumpkin is too big or too small, or their collider is less than ideal. Like this pumpkin, I'm not hitting at all. And when that happens, you know, there's a couple things you can do. You can go to your obstacle script and you can make it only rotate on the Z and instead set the X rotation to 0. That might fix it. You could also make sure to, on your prefabs, on all of them, once again, I'm going to select all of them, command click and unselect the 2 non-obstacles. And in the inspector view, where the rigid body is, in constraints, maybe I want to freeze its position on the Z axis so I don't actually knock it out of space so that it's staying on that Z plane. Maybe that'll help too. You're going to have to play around with it a little bit. All right, now that we have that, let's make our projectile something better. So right now it just has a projectile script and a rigid body. So I'm going to go to the prefabs that came from the polyperfect ones. And there was a candy corn prefab. Here it is. Beautiful. I'll drag that dude up. It's very, very tiny. So let's set the scale to like kind of like that a little bit better. Maybe even, yeah, that's nice. And on this, let's make sure to add the rigid body, low gravity, add the projectile. It is not 0. Let's give it 5. And I'm going to do the same thing. I'm going to unpack the prefab, even though I don't think I need to do that. And then drag it into my prefabs. I could probably just drag it there. All right, there we go. Now I have a candy corn prefab and I can delete this projectile, the original one, by projectile. And delete this. And on the shooter, nope, the center, it's looking for a projectile game object, and I'm gonna drag in, there it is, the one that we just made. Let's make sure this still works. There we go, still works. Ooh, something's a bit weird. I'm guessing on the candy corn here on the mesh collider, let's make it a trigger mesh because it's pass through. It doesn't need to be hitting all of the other colliders like that. Let's see if that fixes it. There we go, much better. Pass through, so it's not doing that weird behavior. All right, sick. Our projectile is updated. Let's add a little bit to our center. So in our center here, if you looked at the original, there was like a cute gradient image behind it. So I'm actually on the center gonna right click and create. Ooh, we don't have any 2D objects. I want a 2D object. So let's go to our window package manager and let's find in the Unity registry, let's search up 2D right here. Let's install this one. All right, now that we have that, hopefully when I right click center, yay, there's a 2D object here. So I want to create a sprite and I'm going to make a circle. And this circle sprite, yep, is looking for a sprite image. Like it just had a regular circle, but maybe I want to import my own art. So I just searched on Google for a radial gradient with a transparent background and found this one. So I'm going to import this or or drag this into my textures folder. Once you have it in here, the alpha is transparency, the texture type is 2D and UI, and hit apply. So now back on the circle, I can drag this into circle. Maybe I want it to be a little bit bigger, so I'm going to say, and maybe I want it to be just a little bit more full than it is. Here we go, like that. Nice. And I suppose the last thing that we need to do is bring in a jar. So I actually 3D modeled a jar real quick in Blender because I wanted a really specific shape, but you can also try your luck and look in the asset store and see if there's maybe a jar that you can use. I'll show you how to make a transparent material if you wind up making your own as well. Super easy. All right, so here's the jar prefab that I made. I'll drag it in, but it also comes with all this other stuff that I modeled. I'm going to delete everything but the jar and the lid. So the jar itself was kind of small, so I'm going to make it like 10, 10. Nice. And then this jar is like an outer container, so I'm going to set the inner jar to 0, 0, so it's really on the center. Well, I guess, no, a little bit more up on the This jar is going to replace this stand-in jar, the square that we had. And all that thing needed is a box collider and a jar script. Let's go to our jar here. Let's add a box collider that is a here, and let's add a script that is our script. But notice that the box collider is kind of gigantic, so let's edit the collider to fit more our actual jar here. I'm gonna go out of 2D mode and make sure, that on the side like this, that it's not extended any bigger. Cool, from all directions, that's looking good. That works for me. Okay, so now we can delete this jar. And let's make sure that this still works. So jar still rotating slowly. Beautiful. All right, let's make it transparent as well. So in the assets folder, I'm going to right click and create a new folder, and I'm going to call this materials. In this folder, we will right click and create a material, and I'm going to call this glass_matte. This material, the rendering mode from opaque to transparent, let's apply it to the bottle, I guess. Set the albedo to be something kind of blue, and then the alpha turned down so that if we put anything inside, we could see. So let's add some candy inside our jar. I'm going to go to the prefabs folder that came with the Holly Perfect. There it is. Because I think I saw some candy in here. All right, so there's a few candies that they gave us. There is a candy pumpkin. I'm going to set that to like 5. More than that, maybe 10. That's kind of big and seeable. Cute. And then maybe I'll add another candy here, a candy A. Also set that. And you can add your own mix of whatever kind of candies you want. I'm of course going to add some candy corn in here. I'm going to duplicate them and place them around. Now, the thing about this is, and here I will duplicate all of these guys. Side. So our jar is really full of candy. Now, the thing about this is, even though all of these candies have a mesh collider, and we can go ahead and add a rigid body, keep the gravity on so that it's going to sort of rattle around in this jar. And I'm going to set all of this candy, I'm going to shift click to the bottom. I'm going to set these as children of the internal jar that I have here, just so my hierarchy is nice and clean. Now, the thing is, when I hit play, look at what happens. Oh no, and some of the ones I duplicated don't have rigid bodies, so hold on here. There we go. So I'm going to select all of those candies, make sure I'm going to add component and have a rigid body with gravity. And now when I hit play, look at what happens. They just fall straight through the jar. Because the jar itself has a box collider that is a trigger. It's only pass through. It doesn't have a box collider to define the outside. And you would think maybe what I do is I add a box collider and I don't check is trigger. But look at what happens then. Here we go. They just shoot out of the jar because they're detecting that collision. So the way that I think might be the best way to do it, maybe somebody has a better idea and can help with that, is we're going to edit the collider. I'm going to remove this box collider from the outer jar. The inner jar here, that's like a child of it, I'm going to add a box collider to here. And then I'm going to edit the collider to be like this outside part. And then now we have a wall on that side of the jar. We're going to add another box, and then this one, hopefully it's the right one. It's not. We're just slowly gonna build the walls of this jar up. Kind of obnoxious, but now I have 2 walls on this side. Ugh, and I made it all small that way. Big, pollinate. Yeah, pretty darn obnoxious, but I think it's the best way to do it. So I'm gonna add yet another box collider, and this one will be that wall. I'm gonna add component, another box collider, and this one will be this wall. We still need a top and a bottom. Yep, we do. I'm gonna add another component, a box collider, and I'm gonna grab the bottom one and drag it up to there. Lastly, one last box collider, grab that one and drag it down so we have a bottom edge. All right, and now we've kind of built a box of boxes around the edges of this jar, and hopefully I did that right, so let's hit play and see. Yay, and now all the candy is piled on the inside. There is one pumpkin kind of leaking out of the jar here, and it might be because of the position of my colliders, right? All right, I see the issue is, right, my colliders are a little bit, so if it's hitting this corner of the jar, it's not gonna. So I'm gonna smallinate my colliders even more. Pull them all this way. Pull them all in so that it doesn't hit. Oh no, this one is giant. What happened? Uh-oh. One of these colliders got way too big. Oh dear Lord. I'm gonna hit undo. Yeah, hopefully by bringing the colliders in, that sort of mitigates some of the problems. Oh, that's so obnoxious. Oh, okay. Well, you can take the time to find the specific collider that is. I am gonna change the speed to be like 50. And let's just make sure that like, all right, they're staying within the jar. I just would take some time to clean up those colliders so as they're hitting the corners, like the box colliders are a little bit smaller than the jar. Now, notice the interesting thing that's happening right now. I'm not actually losing any lives, and that is because the jar is no longer tagged as player. So make sure that if you forgot to do that, the jar has the tag of player. I think, you know, if I took the time to fix up the colliders, it would be really beautiful. But I think with that, yes, there we go. Now our collisions are back to working again. Awesome. And it seems to be working all good. Yay! The last thing to add to this for like our finishing touches would be that particle system that we saw. Sort of like these twinkling lights that are happening here in the background. It looks something like this when we're done with it. To create an effect like this is actually really simple. It's just using a particle system. So go ahead and right click in your hierarchy and you'll create an effect particle system. We want the start speed over here to be 0 so that it'll kind of be twinkling in place. And the start size is going to be kind of small, like maybe 0.5. In the emission, let's go ahead and up that to like 20 and adjust that as well. In shape, we're going to change this from a cone to be like a sphere. And then let's make it way, way bigger, like a 10 radius. Oh, good. Now we can kind of see them on the screen. Maybe 20 is too big. Oh, see, the issue too is my fireflies are off center. So all the way at the top, I'm going to center its position at 0, 0, 0. There we go. Now let's kind of give them some color over lifetime. So find this color over lifetime module, check that. And let's just give it like a few keyframes at the bottom. And maybe it starts white and then maybe it goes nice hello. And then also up at the top, I'm going to add a few keyframes so that maybe this top one, it starts fading out, in, out, in, out. There we go. Now we kind of have a nice flicker fade effect. Let's also go to size over lifetime. And in this curve here, choose the curve that starts high and ends low. And then maybe let's like drag this up a little bit. So it starts high and then they get smaller over time. Yeah, and that's about it. I guess actually we could add some noise to this one. Might be a little bit too strong. So I'm going to set the strength to something smaller, like 0.3. And maybe the frequency a little bit higher, 0.7, 8. Yeah, that's kind of cool. And that's it. Now we have our beautiful fireflies. Cool. Love to see it. Okay, 2 more things that we can add to this. We can add a sound effect for when we shoot a candy corn. And last feature is let's just add some background music to this. So the first thing is you want to find the sound effect that you want to play when your candy corn shoots. For me, I have this sound. It's like a little laser gun shot sound, and I'm going to drag that into my assets folder. There it is, laser gun sound. If you want to preview a sound you have, you can hit the play button here. Love that. I'm also going to organize it, right click my assets folder and create a new folder called sounds. And inside that folder, I will drag laser gun sound effect. Now this sound is really easy to add. We just go to our prefabs folder on the candy corn itself, and let's just add an audio source component. In here, it's looking for an audio clip, and we can pass in the laser gun sound effect. And as long as you have play on awake checked, it's going to play the sound the moment that this candy corn is instantiated. And so we don't actually even have to change that through script. Let's just test, make sure that works. There we go. Beautiful. Love that. All right, let's add our background music. So on the main camera here, we're going to add a component that's also an audio source. And in here, the clip that I'm going to add, I'm also going to check loop, and this clip is going to be the background music. So go ahead and find whatever background music you want. For me, I found this Halloween spooky music by the Heatley Brothers. Sounds a little something like this. And once you have this music, you can go ahead and drag it into your sounds folder. On the main camera, I'm going to drag the Halloween music into that audio clip, and it should automatically play when you hit play. There we go. Really loud music. Perfect. Okay, final thing is let's find some music to play when it's game over. So this will switch what clip is in here, and it will turn off loop, and it will play the game over music one time. So find the song that you like. I found this little 8-bit game over music right here. Perfect. All right, and for one last time, let's go ahead and right click and create a C# script, and I'm going to call this Music Manager. I'm going to attach the Music Manager to the camera, and let's go ahead and open it up. Now, for the final time, let's convert this into a singleton. We've done it it seems like at least 3 times. We've done this for our shooter, for our spawn manager, for our UI manager. So now let's see if you can do it from memory for your music manager. All right, so that's a private static music manager, and I'm going to call it instance. We need the public property called I instance. We only have a get part of this property, and we're just going to null check. And outside the if, but still inside the get, we will return the instance. I'm going to change this start to awake, and in here, we are going to set instance equal to this. Great. Now the script is very simple. All the script is going to be in charge of is holding an audio source, an audio clip, and passing the clip into the source when it's time for game over. So we're going to create a private audio source. I'm going to call it audio. We will have a private audio clip. I will call this game over music. And we will have a public method that's called when it's game over. Public void game over music, perhaps. And inside here, we're just going to say audio.clip equals game over music. So we're passing that in. And then we're turning off that loop thing. We're turning off this loop checkbox here. So to do that, we're just going to say audio.loop false, and we're going to play the clip audio.play. Simple. Let's go ahead and serialize the field for both of these so we can assign them in the inspector. Now on the music manager script, it's looking for a source and some game over music. I'm going to pass in the game over music we found. And for the audio source, I'm actually just going to drag the component in right here since that's the source we want. We could also use get component, but this works as well. Lastly, in the UI manager, all the way where we're calling all of these different methods for when it's game over, we can also call music manager.instance.game over music. Here we go. Save your script. And I think this is it. You can go ahead and play it. All of your sound should be working beautifully. When we get to 0 lives, it should be game over music is playing. Beautiful. All right, give yourself a round of applause if you made it this far. Good job on this starter game, and I will see you in the next one.